Hi everyone, welcome to EASYBOARDS. Today we are going to start with the next chapter, which is the first chapter of physics, which is electricity. Now this is a comparatively lengthier chapter and a very important chapter as well, and this stands as the most fundamental chapter for class 12th physics also. So if you are planning to be in science stream for the years 2000, next 2 years, that is 21 and 22 in class 11th and 12th science stream, then this chapter is going to be extremely important for you because current electricity is a very important chapter in many units of class 12th. So without any time delay, let's get started with this chapter. So to make the study of this chapter easier, I have prepared short notes. So we will be learning with the help of those notes. We will be also solving the important numericals from this chapter and also the in-textual questions in between. So all those things we are going to cover today. So we are going to finish this chapter in a single lecture. This chapter deals with some basic terminologies of current electricity. First one is charge. Second is current. Third is potential. Fourth is potential difference, resistance, Ohm's law, resistivity, conductivity, series connection, parallel connection, heating effects of electric current. Then we'll be discussing about the concept of power. So these are the topics that we are going to cover in this chapter. So starting with the first topic, that is charge. So what exactly is charge? Suppose I have some matter. I am placing this matter in a region of electric field. So wherever electric field is there, I am going to place this matter over there. So what happens is that it will experiences some force when I am keeping it in the region of electric field. This is experiencing this force because of one fundamental characteristic that is known as charge. So charge can be defined as an intrinsic property of matter due to which it experiences a force when kept in a region of electric field. Now, what is the SI unit? That is the standard international unit of charge. It is coulomb, and charge is denoted by the letter capital Q. 1 coulomb is equal to 1 ampere into 1 second. We will define this later. The basic equations which are related to charges, number one is known as quantization principle, which states that the net charge which is present on a body is the integral multiple of the fundamental unit of charge. That means Q is equal to N into E, where N is known as the number of electrons and E is the electronic charge, which is the basic unit of charge, and its value is 1.6 into 10 raised to negative 19 coulomb. Charge in terms of current, we have this equation Q is equal to IT, where Q is the charge, I is the current, and T is the time taken. So from this we can say the unit of charge, that is coulomb, 1 coulomb is equal to unit of current, that is 1 ampere, into unit of time, that is 1 second. So that is how we are getting this particular equation. 1 coulomb is equal to 1 ampere into 1 second. Moving forward with the second topic, that is current. So what exactly is current? Current is defined as the time rate of flow of electric charge in a circuit. That means if I have a conductor something like this, in this conductor some amount of charge is constantly being flowing. The amount of charge that is flowing through this conductor in 1 second, that is defined as the that is defined as the current. So if I go with the equation of current, it is given by del Q divided by del T. Now this letter, this triangle is used to denote change, and it is a Greek letter known as delta, or we read it as del. So del means change. So del Q by del T means it is the change in charge divided by change in time. So in a particular change in time, how much charge is being transferred, that is known as current. So let us assume that a particular time t1 the charge is q1, and at a time t2 the charge is q2. Then the change in charge, that is q2 minus q1, divided by the change in time, that is t2 minus t1, is going to be the current. So I is equal to q2 minus q1 divided by t2 minus t1. Or another equation is Ne divided by T, because we know that Q is equal to Ne. SI unit is going to be ampere. Other units are going to be microamperes and milliamperes. 1 microampere is equal to 10 raised to minus 6 ampere, and milliampere is equal to 10 raised to minus 3 ampere. Microampere is used to measure the current in a Zener diode, which is acting as the voltage regulators in televisions, and LEDs and solar cells, the current is measured in terms of milliampere. To measure the amount of current that is flowing through a circuit, we use a device, and that device which is used to measure the current in a circuit is known as ammeter. The symbol for ammeter is represented below. We will just put a circle, and inside the circle we will write an A. So this is the basic concepts of current. Unit of current is ampere, and current is denoted by the symbol I. Now, what is the direction of current? So here I have taken a conductor, a cylinder shaped conductor AB, right? So here let us assume that the electron is moving from the end B to the end A. So electron is moving from the end B towards the end A. So if electron is moving from B to A, what will be the direction of my current? The current that is flowing will be opposite to the direction of electron flow. That means the current, which is also known as the conventional current, because we are placing the convention, so that current is going to flow from A to B. The charge due to electron will also form a current which is known as electronic current, that will be flowing from B to A. So the current in a circuit will flow in a direction opposite to the motion of the motion of electrons. So that is the most important point that we have to note related to conventional current. Now let us do a question related to the charge equation. Calculate the number of electrons constituting 1 coulomb of charge. This is an intextual question, so let us solve this. So here it is given, we have to find the number of electrons, that is n, constituting 1 coulomb of charge. So here the Q is given as 1 coulomb and n we have to find. What is the equation connecting these two, Q and n? It is Q is equal to Ne, and we know the value of E is equal to 1.6 into 10 raised to minus 19 coulomb. So N is equal to Q divided by E, that is coming out to be 1 divided by 1.6 into 10 raised to minus 19 coulomb. So that on simplification we will get it as 6.25 into 10 raised to 18 electrons, and please do note that this is a standard value. 1 coulomb will have 6.25 into 10 raised to 18 electrons. It's a standardized value. And if this question comes for the examination, it will be asked as a 1 mark question. For writing the formula and writing the given values, that is these two, you will be getting a half mark, and for the simplification part, you will be getting another half mark. That is how 1 mark is distributed for this question. Moving forward with the second question, a current of 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes. Calculate the amount of charge that flows through the circuit. That's the question. So here current is given, that is 0.5 ampere. Time is also given, that is 10 minutes. Always convert everything into SI units, and the SI unit of time is in seconds, so we have to convert this 10 minutes into seconds. That is 10 into 60 is equal to 600 seconds. Once you write this much, you will be awarded half mark. Half mark is for writing the formula, so that is Q is equal to IT. Once we get the formula, we have to do substitution. Without doing substitution, you won't get this half mark. So please do the substitution and simplification, final answer. So upon simplification, we will get it as 300 coulomb. Do not stop with that. You have to write a conclusion statement. We have got that Q is equal to 300 coulomb. Do not hesitate to write a conclusion that the amount of charge that is flowing through the circuit in 10 minutes is 300 coulomb. This completes your answer. Let us move on to the next question. Define the unit of current, or it can also be asked as define 1 ampere. 1 ampere is the 1 ampere is defined as the current which is constituted by the flow of 1 coulomb charge per second. So for this you will get half mark, and for this you will get half mark. 1 ampere is equal to 1 coulomb divided by 1 second. It is again a 1 mark question. Moving forward with the next concept, that is electric circuit. So what is a circuit? I will draw a simple circle over here. What is the peculiarity of a circle? I'm going to consider a point over here, and if I start running from here, I'm going to reach the same point again after a certain duration of time. That means this is going to be a closed loop. Any such closed loop in which current is flowing is known as an electric circuit. So a continuous and a closed path of electric current is called as an electric circuit. So this is an example for electric circuit. But how to draw these type of circuit, we are going to learn that in some time. So to draw a circuit, we have to first know what is the symbol for the various circuit elements. So let us study the symbols one by one. First one is an electric cell. So for drawing an electric cell, first step is you have to draw a wire. This is how you draw a wire. Now, an electric cell consists of a positive terminal as well as a negative terminal. For positive terminal, draw a big size line, and for the negative terminal, draw a small size line. Again, you have to draw wire. There should not be any interruptions in between except this space. Now here you can put a positive sign and here you can put a negative sign, and this completes the sign of a cell. This is a single cell. Now if you have to make the symbol for a connection of cells, which is also known as battery, then you can make it like this. We have a wire, positive terminal, negative terminal, connecting, positive, negative, again connection, positive, negative. This is how, as many number of cells as you want. And please do not forget to put the sign, that is positive and negative sign. Next is that of a switch. So for switch, it is also known as a plug key. Switch is also known as a plug key. So there are two methods of representation of a plug key. Either you can put it like this. This means that the switch is in off position, and if you're putting it like this, that means it is in on position. This is on position. Another way, a more classic way of representation is this. If you put a simple bracket like this, that means it's an open circuit, and if you put a dot here, that is a closed circuit. Next is a wire joint. Wire joint means if one wire is coming like this, another wire is coming like this, there is an intersection over here, so that is known as a wire joint. Now if a wire is passing over another wire without joining, that means if this wire have to pass through without joining with this wire, then it have to take a loop like this. So this is the representation for wire crossing without joining. Electric bulb, this is the representation. If you want, you can put it in a circle also, there is no issue for that. Now talking about the resistance. For resistance, you're going to start like this, down, up, down, up, down. This is how you're going to represent a resistor. Now for rheostat, which is also known as variable resistor, you're going to put a arrow also on the resistance. Or another way of representation is you can put it like this as well. So these are the two ways in which you can represent a rheostat. Next is the ammeter. So how to represent ammeter? We just have to put a circle and there you have to write an A. For voltmeter, a circle and inside that V. For galvanometer, a circle, inside that G. So these are the representation of the various circuit elements. So using this, let us draw some simple circuits now. Okay, so now let us start constructing a simple circuit, which is consisting of a bulb, a switch and a battery. A simple circuit. So first of all, I'm going to start with the cell. This is a cell, a switch, and now I'm going to connect it to a battery, sorry, a bulb. So this is the circuit. But now, is the bulb glowing? Answer is no. Reason, the switch is closed. So we have to put a dot here, and if you're putting a dot, that means now this is going to be an open circuit. So now the bulb will start glowing. So this is the representation of a circuit. But now again the circuit is incomplete because you have to show the arrow representation of the direction of current. Current always flows from the positive terminal of the cell to the negative terminal. So you have to put the arrow in this particular direction. Moving forward with another circuit. Let us draw a big circuit which is having a resistor, a cell, a bulb, and let us connect an ammeter to measure the current. Let us also connect a voltmeter to measure the potential difference. So we will study about what is potential difference, but just now understand that we are also going to measure the potential difference. So first let us draw a resistor, and now we are going to connect it to a cell, a switch. Always remember that the ammeter is connected in series with the resistor. That means you can connect it like this. However, for connecting a voltmeter, that should always be connected in parallel with the resistor. So now the circuit is complete, the current will flows, and you can see the reflection in the ammeter as well as you can see a deflection in the voltmeter. Deflection in the voltmeter can be adjusted by changing the potential difference of the cell. That means you can change the number of cells so as to change the potential difference, and this can be changed if you connect a rheostat over here. If you have a rheostat, you can slide the rheostat, and when you're sliding the rheostat, you can adjust the resistance, and correspondingly the current will also changes. So this is how we are constructing a circuit diagram. Now let us learn about the concept of electric potential. What is electric potential? Electric potential is defined as the work done in bringing a unit positive charge from infinity to the point under consideration. Now what does it mean? Suppose we have a charge which is sitting at infinity, beyond our imagination. From that particular imaginary point, we are going to bring this charge to a point, say over here. How much work is required for bringing this charge from infinity to this particular point of consideration? That amount of work is known as electric potential. So electric potential equation is V is equal to change in work done divided by change in charge, that is delta W divided by delta Q. This equation is also important. Questions related to this can be asked. Numericals can be asked. Now the potential in a circuit is maintained by a device which is known as electric cell. This is important. For measuring the potential, you need potential difference, you need voltmeter, and for maintaining potential in a circuit, you need a cell. Unit of potential is volt, that is again denoted by V. So this is the basic concept of electric potential. Now let us talk about potential difference across 2 points in a circuit. So here you can see 2 points. This is A and this is B. So the current is flowing from A to B. What about the potential difference? The work done in moving a charge, it is not a unit positive charge, any charge. The work done in moving this charge from the point A to the point B is known as the potential difference. The work done in moving a charge from one point of the circuit to another point of the circuit is known as electric potential difference. So potential difference can never be denoted by V. It's a mistake in NCERT. Please do correct it, that potential difference is always defined as a difference. So it can either be denoted as delta V or it can be denoted as VA minus VB, where VA is the potential at the point A and VB is the potential at the point B. Unit of potential difference is volt, that is denoted by the letter V, and VA minus VB, that is the potential difference, is the work done divided by the magnitude of the charge. For measuring the potential difference, you have the voltmeter, which is connected in parallel with the circuit. These are the important points which you have to note related to potential difference. So make sure that you understood these two terms, potential and potential difference. Potential means from infinity you are bringing a charge into point of consideration, and potential difference means you are moving a charge from one point to another point inside a circuit. For maintaining potential, you need cell. For measuring the potential difference, you need a voltmeter. These can be some confusing questions which can be asked as 1 mark question and can kill your marks also. So please be careful with these 3 points. Measuring current, ammeter; measuring potential difference is voltmeter; and maintaining potential or potential difference is the cell. Moving on to the most important topic of this chapter, that is Ohm's law. This is the fundamental topic of physics. So let us learn what is Ohm's law. For learning Ohm's law, we have to understand this thing. We learn 2 quantities now: potential difference, another one is current. So from now onwards, we are going to represent potential difference as V again. Although it's not a correct representation, but still as per NCERT it is given as V. So from here onwards, we are going to represent potential difference as V itself. So this potential difference is related to current, and that relation with current is explained by Ohm's law. What is Ohm's law stating? Suppose I have a resistance. This resistance is connected to a voltmeter in parallel, and it is connected to an ammeter, then to a battery or a cell, and then to a switch. The switch is on, so the current is flowing. Now what happens is that if I am adjusting the resistance by using a rheostat, I can see that the amount of current is changing. When the current is changing, correspondingly the voltage or the potential difference is also changing. Once again I am repeating, when I am changing the magnitude of current, I can see that the voltage or the potential difference is also changing. And if I plot a relationship between the change in potential and change in current, I got a graph like this, which is a straight line graph. So we can say that the potential V was directly proportional to the current I. So to avoid this constant of proportionality, we can write V is equal to a constant into I. And this constant of proportionality is known as resistance. So V is equal to R into I, where R is called as resistance. Now what is resistance? Resistance is defined as the hindrance or the obstruction to the flow of electric charge in the circuit. That means if current is coming through the way, now this particular conductor will say, no, don't flow through me. This particular ability of the conductor to resist the flow of electric current is known as resistance. Resistance is denoted by the letter capital R. Unit of resistance is ohm, that is represented by this particular symbol. 1 ohm is equal to 1 volt divided by 1 ampere. Equation for resistance: R is equal to V divided by I. For changing the resistance in a circuit, we have rheostat. We cannot measure resistance directly. We can measure it by using a voltmeter and an ammeter together. Okay, we have to connect the voltmeter in parallel and ammeter in series. We can measure the potential difference and we can measure the current separately, and from there we can calculate the resistance by using this equation. We does not have any device for measuring the value of resistance correctly. Now from the VI graph, the slope of the graph, that is the change in Y quantity divided by the change in X quantity, that is known as the slope. So that slope is going to be V2 minus V1 divided by V1 I1 minus I2 minus I1, or that is equal to R, that is the resistance. Now talking about the factors affecting resistance, I told you that V is equal to IR, so R is equal to V divided by I. So now if I ask what are the factors affecting resistance, many students will be telling that it depends on V, it depends on I. Well, the answer is incorrect. The current can change, but correspondingly the potential difference also change. So even if there is a change in current, there will be a corresponding change in the potential difference, so that the value of resistance always remains a constant. Imagine the current was 5 ampere and the potential difference was 2 volt. If the current is changed to 10 ampere, then the potential difference will also change to 4 volt. So here both have changed in a fraction, so that the value of resistance does not change. So from this we can conclude that the resistance does not depend on the potential difference of the circuit. It does not depend on the current that is flowing also. So what are the factors that is affecting resistance? First factor is length of the conductor. Second factor is area of cross section of the conductor, and third is the temperature. How is it affected with the length of the conductor? It is directly proportional to the length of the conductor. That means if we are increasing the length of the conductor, then resistance increases. Suppose the initial length of a conductor is L, I am increasing its length to 2L, then the resistance will become 2 times. If I'm changing the area keeping the length constant, then it is inversely proportional to area. So when area is increased, resistance decreases, and when area is decreased, resistance increases. And it has a relationship with temperature also. RT is equal to R0 into 1 plus alpha delta T. This is not required at class 10th level. You will learn it in class 11th and class 12th, but not at class 10th level. So we are going to combine the first and the second equation to get R is directly proportional to L by A, or we can use a constant of proportionality, that is rho. Rho is known as a resistivity of the material, and it is a characteristic property of a material. Like you give a price tag to a material, right? So this resistivity is also a characteristic of a material, just like a price tag. That depends on L and A. It again does not depend on potential difference and current. Now we will define resistivity. Now defining resistivity or defining any physical quantity when you have the equation is very simple. So I will explain how to define physical quantities when the equation is given. We have R is equal to rho into L divided by A. From this we can say that rho is equal to R into A divided by L. Let us assume that this area is 1 meter square and this length is 1 meter. Now what is resistivity here? Resistivity becomes equal to resistance when area of cross section is 1 meter square and length of the conductor is 1 meter. So what is my conclusion here? Resistivity is the resistance of a material whose area of cross section is 1 meter square and whose length is 1 meter. So that is the definition for resistivity. Resistivity is defined as resistance of a material whose length is 1 meter and area of cross section is 1 meter square. So what is the unit of resistivity? Let us see. Unit of resistivity is equal to unit of resistance, that is ohm, into meter square divided by meter. So 1 meter and 1 meter will cancel over here and we will get it as an ohm meter. So the unit is ohm meter, and the range of resistivity for metals is between 10 raised to minus 8 ohm meter to 10 raised to minus 6 ohm meter, and for insulators, that are substances which does not conduct electricity, that is between 10 raised to minus 12 meter to 10 raised to minus 17 meter. So which is greater? 10 raised to minus 6 is greater than 10 raised to minus 12. So we can say that for conductors, resistivity is more, right, and current will flow through it easily, so we can say resistance is less. More resistivity, less resistance. For insulators, more resistance and less resistivity. Now, these are some of the questions which can be asked based on resistivity. These are some applications, real life applications of resistivity, which is mentioned in NCERT, and these are the questions which can be asked from that. So let us discuss this concept with questions. First question is, why alloys are used in heating devices such as toaster? Second question, why tungsten is used for filaments in electric bulbs? And the third question is, why copper and aluminum are used in electric transmission lines? So let us answer each of these in detail. We know that resistivity of an alloy is always greater than that of its constituent metals. So this is an important point to note. Alloy is prepared by mixing of metals. So the resistivity of an alloy is always higher than the constituent metals, and they do not burn readily at higher temperatures, and hence they are used as heating devices. Due to their high resistivity, tungsten is used in filaments. Because it is having high resistivity, it does not burn easily. That is the reason. And copper and alloy is used in transmission cables because of their lower resistance. So these are the three answers for these questions. Alloys are used in heating devices because they are having better resistivity as compared to normal metals. Tungsten is used because tungsten is having high resistivity, it does not burn out easily. Copper and aluminum are used in electric transmission lines because of their lower resistance, and hence current can flow through it easily. So this is the answer for these three questions. Please take a note. Now next question. How much current will an electric bulb draw from a 220 volt source if the resistance of the bulb is 100 ohm? Very easy question. V is given, R is given. We have to find I. Use V is equal to IR, I is equal to V by R. Substituting, we will get it as 2.2 ampere. And please do note, first you have to write the given value, half mark, equation, half mark, simplification, half mark. You have to write the conclusion, that also will carry half mark. Always follow this 4-step procedure for any numerical question, be it physics, chemistry or biology, genetics or ecology questions. Moving on with the next question. An electric bulb and a heater are connected in parallel with a 220 volt source. If the resistance of the bulb filament is twice that of the heater coil, which one will fuse out more quickly if there is a high voltage supply? Assume that the resistance of the bulb is 100 ohm. Now this is a little difficult question, and this is specifically framed for the students who are preparing for competitive examinations. Here what is given? We have an electric bulb and we have a heater. Both of these are connected in parallel. That means if one is connected over here, one is connected over here. And both of these are connected to 220 volt source. Parallel with a 220 volt source means both these devices are going to get the same potential differences. That is the meaning. Resistance of the bulb filament is twice that of the heater coil. Bulb is 100 and that 100 is twice that of heater coil. That means heater coil is having a resistance of 50 ohm and bulb filament is having that of 100 ohm. Now let us find out what is the current that is flowing through bulb and also current that is flowing through heater. Current flowing through bulb is going to be 2.2 ohm and the current that is flowing through the heater is 1.1 ohm. Since more current is flowing through the bulb, first the bulb is going to fuse out. So when more current is flowing through something, and whenever there is a high voltage, the device which is drawing maximum current, that is going to fuse out first. So that is why this bulb is going to fuse out first. So that is a conceptual question. Please take a note of this question. The potential difference between two terminals of an electric heater is 60 volt. So potential difference is given. It draws a current of 4 ampere. What current will the heater draw if the potential difference is increased to 120 volt? So now there is a tendency that the student will say that it is just the double, right? But that is wrong. Reason being, first case there is 60 volt and 4 ampere. So the resistance will be 60 by 4, that is 15 ohm. Second case, current will be equal to V divided by R, that is equal to 120 divided by the resistance, that is 15 ohm, that is 8 ampere. I told you that when voltage is increased, current increases in the same fashion, right? So we have to find the resistance, that is always a constant. So find the constant, and from there only you have to calculate what is the current that is flowing through the circuit. Next one is a question related to resistivity. This is a very important question. Resistance of metal wire of length 1 meter is 2.6 ohm at 20 degrees Celsius. This is not required actually. If the diameter of the wire is 0.3 millimeter, then calculate the resistivity of the material at this temperature. So rho is equal to Ra by L. Here A is equal to pi R square, right? It is a cylinder. Cylinder wire means the cross section should be circle, and area of circle is pi R square. Here diameter is given. So diameter is equal to, radius is equal to diameter divided by 2. So here the area is equal to pi into d by 2 the whole square. First calculate the area, and once we get the area, we have to substitute in this equation. So that is how we have to simplify this question. This is a very good question, and it is very important one also. It is asked in board examinations many times. A 4 ohm resistance wire is doubled in length and reduced to half in area. Calculate its new resistance. So here what we have to do, I'll do this problem here. We know that R is equal to rho into L divided by A. This is a constant, so we can take R is directly proportional to L divided by A. So R1 by R2, R1 is the initial case and R2 is the new case. That is equal to initial length divided by final length into, this is inverse, right? So it is 1 by A1 divided by 1 by A2. So that A2 will come up. So that is same as into A2 by A1. So R1 by R2 is equal to L1 by L2 into A2 by A1. Now you have to substitute the values here. Substituting, we will be getting it as 4 times of R, 4 times of the initial resistance, and initial resistance is given as 4 ohm. So multiplying, we'll be getting it as 16 ohm. This is again asked as a 2-mark question for the board examination. Moving on to the next topic, that is system of resistors. Little bit clarity problem. No problem, in the notes that is mentioned in the description box, it will be clear. First one is the series combination and second is the parallel combination. Starting with the first one, that is the series combination. Please do note that in series combination, the current that is flowing through the circuit is constant, and in parallel combination, the potential difference remain the same. So this is a very important point. In series combination, current flowing through the circuit is the same and through every elements, and in parallel combination, the potential difference is same. So you can remember it as PP, parallel combination, potential difference same, and series combination, I is same, that is current is same. So now let us learn about the equations of the net resistance in series and parallel combination. So consider that many resistors are connected in series. Then the net potential difference, that is V, is equal to the sum of potential difference across each of these resistors. So we can say V is equal to V1 plus V2 plus V3, and we know that V is equal to IR. So current is same through each of these elements, so we can write IR1 plus IR2 plus IR3 plus etc. And V total is nothing but IRS. So that IRS is equal to I into R1 plus R2 plus R3 plus etc. And current is same, so we can cancel on both sides to get RS is equal to R1 plus R2 plus R3 plus etc. That is the equation. So RS is equal to sigma Ri. This is the simplified equation for series combination. Now coming to parallel combination, here the potential difference remains the same and the current that is flowing through the circuit is the net sum of the current that is through each of the individual resistors. So I total is equal to I1 plus I2 plus I3 plus etc. So I is equal to V by R. So V by R total is equal to V by R1 plus V by R2 plus etc. So that is how you are getting it as 1 by R total is equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus etc. That is, we are getting 1 by R total is equal to sigma 1 by Ri. This is the simplified equation for parallel combination. So if we have two resistors in parallel, suppose something like this, then one is R1 and another is R2, then 1 by Rp is equal to 1 by R1 plus 1 by R2. So this is equal to R2 plus R1 divided by R1 R2. That is equal to 1 by Rp. So what is the equation for Rp? Rp is equal to R1 R2 divided by R1 plus R2. So this is the equation for two resistors in parallel, R1 R2 divided by R1 plus R2. Now this is the practical application of series and parallel combination. So let us solve this one. You are to set up an electric device at your home. What type of connection would you prefer and why? Is it series combination or parallel combination? Now we know that current divides in parallel combination and potential difference divides in series combination, right? So in series combination, if I am connecting a bulb, a heater, a toaster and a television, in series combination what happens? The current that is flowing through each of these will be the same. But we know that the current required for a television will be much higher as compared to an electric bulb, right? So the TV starts dimming, and if anything happens to one of these elements, what happens? The complete elements which are connected in series, they will get damaged. This is why in functions what happens, that small bulbs are there, right? That fairy lamps that you call it as. So if one of these fairy lamps get damaged, the complete thing will get damaged. So the same thing happens here also. If one of the gadgets gets damaged, the complete damage, which are complete devices which are connected in series, they gets damaged. And that is the reason why we do not use series combination for domestic purposes. Rather we use parallel, because there the current splits. So each of the device is going to get its desired amount of current. So that is the answer for that, and the reason is given over here. Current divides in parallel circuit only, hence every element gets desired amount of current as required. If one element is damaged, then all elements fail to work in series combination, hence parallel combination is better in household gadgets. Next, this is another numerical. Calculate the current through each resistor. So here it is connected in series, so everywhere you have this 12 volt, so you can calculate I is equal to V by R. It's very easy question. You can find I1, I2 and I3. Finding the total current is the sum of the individual current, so that is 2.4 plus 1.2 plus 0.4. Total resistance is equal to total potential difference divided by total current, so you can get it easily. That is equal to 3 ohm. Direct question. Now this is a little tricky question. An electric lamp of 100 ohm, toaster of resistance 50 ohm and a water filter of resistance 500 ohm are connected in parallel to a 220 volt source. Calculate the resistance of the electric iron connected to the same source that takes as much current as all three appliances, and what is the current through it. So here we can see that an electric lamp of 100 ohm, toaster of 50 ohm and water filter of 500 ohm, they are connected in parallel. That is this. We can find out the net resistance of this arrangement. To this, another electric iron is connected. So first of all we have to find this Rp, and then we have to find the potential difference. Potential difference is equal to 11 ampere, that is flowing through this connection. This parallel, this parallel, the current flowing is, potential difference is 11 ampere. Current flowing is 11 ampere. And after that what you have to do is we have to find the current that is flowing through the other one. because these two are now in series, so the current that is flowing through this and this is going to be the same. So now you can find the current through the electric iron, that is coming out to be 11 ampere. Once you get the current, the potential difference is known, so you can find the resistance easily because V is equal to IR. From that you can easily calculate the resistance. So this is how you have to proceed with these questions. Next is, how can the resistors of resistances 2 ohm, 3 ohm and 6 ohm can be connected to give the total resistance of 4 ohm and another is 1 ohm. So this can be proceeded by hit and trial method. First, 2 ohm is there, 3 ohm is there, 6 ohm is there. So if all these three are connected in series, the net resistance will be 2 plus 3, 5 plus 6, 11 ohm. So that cannot be possible. Now let us try connecting each of these in series, sorry, in parallel. So now you get a case like this, 1 by 2 plus 1 by 3 plus 1 by 6. That will be 1 ohm. So now you solve this one. Now connect one in series with other two in parallel. Check for different cases. First I am going to take 2 in series with 3 and 6. So that time I will be getting it as 4 ohm. So like this you have to proceed for different cases and find out which one is obeying our necessary condition and proceed. This is a hit and trial method question. So now let's move on to another very important topic, that is the thermal effects of electric current. You might have all used an electric iron, right? So an electric iron, as you know, it gets heated up. Now why is it getting heated up? The reason is because there is an effect which is called as the Joule-Thomson effect or the heating effect of electric current. It is due to this effect that the iron toasters or the electric iron, they get heated up. What happens is that in a purely resistive circuit, if only resistor is present and no inductor, no capacitor, nothing is present, then some amount of energy that is flowing through the circuit is coming out. It is coming out in the form of heat. This process is called as the heating effect of electric current. Now, let us assume that the current that is flowing through the resistor is I and the resistor is having a resistance R. Potential difference across two ends of the resistor is V, and let us assume that the charge that is flowing through the circuit in a time t is Q. Then the work done in moving the charge Q through the potential difference V is given by W is equal to V into Q, as I have told before. Now the power is equal to work done divided by time, right? It is work done divided by time. So we can say power is equal to Q into V divided by T. Q by T, as we know, is current. So P is equal to V into I. So this is the equation for electric power. Electric power P is equal to V into I, where V is the potential difference and I is the current. This is a very famous equation. So please take a note of that equation. Now what is the heat dissipated? Heat dissipated is energy, and energy is power into time, right? Energy is power into time. So that is equal to V into I into T, that is VIT. So that is another equation for heat. H is equal to VIT. Now applying Ohm's law, we have V is equal to IR. So either you can substitute for V or you can substitute for I. If you're substituting for V over here, you will be getting it as I square RT. And if you're substituting it for I, we can write it as V by R. So substituting over here, V square RT by, sorry, this is V into V by R into T. So it is V square T divided by R. That is another equation for heat dissipated. So different equations are there, VIT, V square T divided by R, or it can be I square RT. Three equations are possible for heat dissipated out. So we can say that it depends on the potential difference, it can depend on the current, it depends on the time as per different equations. Sometimes it can depend on the resistance also in different cases. Now let us see the practical applications of Joule's effect. Number one, why tungsten is used in making filaments in electric bulb. This we have already mentioned, but now we are going to explain it again. A bulb, as you know, if you take a bulb, inside the bulb you can see the filament and there is an insulating support also. This filament is made up of tungsten. It is used so because it is having very high melting point. Since it is having a very high melting point of 3380 degrees Celsius, it does not melt at ordinary conditions. It does not melt even at 1000 or 2000 degrees Celsius. So it can withstand such a high temperature that it is used as a filament in electric bulb, because electric bulb gets heated up very fast, right? So it have to tolerate, or it have to hold all those heat. So for that purpose, it is having an extremely high melting point of 3380 degree Celsius. And the insulating support is made up of inactive nitrogen or argon, so that that particular gas does not conduct electricity. Now, what is a fuse and what is the purpose of a fuse? Fuse, as we know, is a safety device which protects the appliances by stopping the flow of the unduly high current. And how are we connecting that? That is connected in series. The fuse is connected in series with the circuit, and it consists of a metal or an alloy of appropriate melting point. So when some amount of extreme high current is flowing through the appliance, the same current is going to flow through the fuse also. Now fuse is having a very less melting point. So what happens is this fuse will break down. And when the fuse will break down, I told you earlier that if one of the gadgets in series combination gets damaged, then the complete elements will stop working. So here also the same thing is going to happen. The fuse is going to stop working. So the appliances which are connected in series with the fuse, even that is going to stop working. So that is how the fuse is acting as a safety device. So this melts the fuse and breaks the circuit. This is encased in a cartridge of porcelain. Now, the next one is electric power. Electric power is equal to VI, and SI unit is watt, and 1 watt is equal to 1 volt into 1 ampere, because the equation is V into I. Other units are kilowatt, and these are some commonly used units of energy, that is kilowatt hour and watt hour. Now we are going to study the relation between 1 kilowatt hour and joule. 1 kilowatt hour is equal to 1000 watt into 3600 seconds, because 1 hour is equal to 3600 seconds, 60 into 60 seconds. So it is equal to 3.6 into 10 raised to 6 watt second, or it is 3.6 into 10 raised to 6 joule. An electric iron of resistance 20 ohm takes a current of 5 ampere. Calculate the heat developed in 30 seconds. Here the resistance is equal to 20 ohm, that is mentioned in the question. It takes a current of 5 ampere. We have to find what is the heat developed in 30 seconds. So everything is given in the question. I is given, R is given, and T is given. We have to find H. So we have to find the equation for H in terms of I, R, and T. And the equation connecting H, I, R, and T is H is equal to I square RT. So substituting all the values over here, we get the answer as 15,000 joule or 15 kilojoule. Calculate the heat generated while transferring this much coulomb of charge in 1 hour through a potential difference of 5600 volt. So heat is equal to V into I into T, right? So that is equal to 50 into 96,000, that is the charge that is flowing, right? So charge is equal to, we have directly this equation, V into Q. So we can just substitute over here 50 into 96,500. This 1 hour is actually useless here over here. Next, a fridge rated 400 watt operates 8 hours per day. Calculate the cost of energy to operate it for 30 days at rupees 3 per kilowatt hour. So the energy consumed is equal to 400 watts into 8 hours per day into, in a month is asked, so it should be 30 days. So that will comes out to be 96 kilowatt hour. Now what is the required cost? Required cost is 96 kilowatt hour into, for 1 kilowatt hour rupees 3 is required. So it is coming out to be rupees 288. So this is an applied question, and this is also an important question for the board examination. So with this we complete the chapter current electricity. This chapter had a lot of concepts and a lot of numericals as well. So if you have liked this video, if you have understood the concepts, please do like the video and also share it with your friends. And all the doubts and queries, please do mention in the comment section below, and also do download the same handwritten notes from the description box which is given below. So in the next lecture we are going to start with the second chapter of chemistry, that is acids, bases and salts. So see you again in the next lecture. Till then, goodbye and happy learning.